Doing that, Fabio is going to
Sure.
be presenting on a comprehensive data management system that was built specifically for the CIGOM project and which centralizes and organizes a great deal of data from different sources, particularly physical oceanography parameters and model results.
Yes. Yeah. Thank you, Sharon. I guess you're seeing my screen right now. And I'm gonna just go with it.
Hang on a
And
second.
well,
Hang on, I don't see your screen. I have an empty screen, but it says that you are sharing. Can you try it again? There we go.
yes.
Yes.
Okay. Yes. There.
Thank you.
Okay. Awesome. Thank you. Well, hello. Good morning, everyone. My name is Favio Medrano, and I'm currently have the role as a data warehouse manager for the Ocean Observational Network in the Gulf of Mexico that was deployed by CIGOM. I also work in CICESE, and well, I'm glad to be talking to you today. I will show you what we do, the challenge that we face, and currently the current data services that we offer. Uh, well, to all this computing infrastructure, the services that we provide, we call them the Comprehensive Data Management System, SMET for short. I included the names of our team members in this slide. They have participated in this SMET project in different time frames, but yeah, those are the people that been working to make this possible. And yeah, so who we are. The Comprehensive Data Management System, SMIT, was born as the need for CIGOM to establish from the very beginning of this foundation a standardized way to manage the data generated from the Ocean Observational Network to be deployed in the Gulf of Mexico. So our team was entrusted the task of defining the procedures to efficiently operate, coordinate, integrate a comprehensive database of the in situ observations and products of operational oceanography. So we collaborate closely with the teams that deploy this network to integrate tightly into their data flows to have a homogenized, fully described and quality data products. Two of these teams had the chance to show their work in previous presentations. The Orco, that leads Javier Flores for the high frequency raters, and the glider teams that leads the Dr. Enrique Payas. And so our current data availability in our platform is this. In our database, we have more than 390 data products from high frequency radar, coastal, ocean, and meteorological buoys, glider missions too. All this started intermittently from 2017 to the present. It's obvious to say that the coronavirus pandemic had a huge impact in our operations, as you can see this big time gap. We also kept a catalog of synthetic aperture radar images of the Gulf of Mexico from February 2011 to the present at different regions and times. These images are from Sentinel-1A, 1B, Tandem X, TerraSAR X, and MBSat satellites. Unfortunately, the access to these data sets is currently exclusive to the funding agencies, the government institutions like Pemex, Semarco, NACID, but the plan in the near future is to be public until the commitments to these agencies are fulfilled. Yeah, our goals are, as a teams aims to facilitate the task of storage, cataloging, discovery, transmission, and visualization of scientific data through well-established protocols at the international level, thereby try to achieve intergroup and interdisciplinary compatibility. Our particular goals are to was to establish the methodology for the homogeneous integration of the ocean data, define our data storage formats and the metadata conventions to achieve the definitive description of the content, and doing so, improving the quality, preservation time, and usefulness. And the continual development of visualization platforms and visualization tools that allows the display of information with new, friendly, intuitive interfaces to facilitate the decision making and the data exploration too. So we followed the steps of established observatories, of well-established observatories and laboratories, and applied the principles, the technologies, and standards used in that scientific community. We stuck with the open of our services, and through the revisions of these standards and these technologies, we merge and match where the SIGOM requirements and constraints kind of match to these principles. So we selected open source technologies for data distribution. Well, I guess I'm going to the next slide. Okay, so for our getting our hands on in the problem, we started working our way from the inner layers, trying to define the formats, the metadata standards, and supply our teams with the information, documentation, resources, and tools to do this. Then in the next step, we selected open source technologies for the data distribution and developed tools to connect the in-between gaps. We used threads and AirDAP data service for our data distribution, and also provide like how-to tutorials, information on how to install them, configure them, and use them, not only for our team, but for the data provider teams. And also very important, on top of this, we have a client web application that uses the data services to explore, to visualize in an organized way all the consolidated products of SIGOM. So what we did was to we decided to use for everyone's convenience to store all the observational data in the NetCA format. We attached to it the climate and forecast conventions for the data structures within the NetCA file, and describe the dataset information with the ACDD metadata standard, which is the attribute conventions for dataset discovery. Well, this helps us to have a definite way to store, describe the data products, as one of the requirements for SIGOM was to physically deliver this data to the funding agencies and external hard drives. We have a website deployed with this data, policy, all this documentation. We have resources, cookbooks, and data samples to facilitate this task to our data providers. We also assist technically in this task. We, with the assistance of CICESE, the IT department, and our team installed and maintain a high availability computing infrastructure to provide these data storage services and host all the software stack. We deployed threads and AirDAP servers for data distribution, as they provide, as you know, many valuable features to search, download, visualize scientific data in many formats to humans and machines. And we also used containerized versions of these servers using Docker, and we provide these recipes on how to install and configure them. And so we offer this to our data providers so they can self-host their own AirDAP or thread servers in their own infrastructures. So we keep mirrors of data in different institutions. To connect our information, that information gaps between the thread service and our interactive map, we develop a web service to request dynamic custom plots and get the data in custom formatted geospatial formats. I will show you in the following slides how what we do with the service. And yeah, finally, we also maintain updated records of our data products in a centralized digital library. This service provides human and machine methods to discover and federate to higher level libraries and, or open portals. We use this library to keep updated information of data sets from all the distribution servers deployed in 3 different institutions. one and well, different institutions located in different places. So we collect all that information, and all those other data servers all use containerized custom versions of the AirDAP server that we deployed. So for the topmost project is this interactive map. And to build that interactive map, we use the Terria.js framework, which is an open source project developed by Data61, an Australian science agency. And this framework helps us to build the visual representation of the SIGOM data products. And it's based on data formats and the Open Geospatial Consortium protocols to display the data. Some of its features are that this is a HTML5 responsive app, usable on PC and on mobile screens, has an accurately organized catalog of our data sets that can be explored easily, has panels to show rich description of the data set that can include image, tables, links, etc. A single map panel to show in the way of stacking layers of data to make compositions of data visualizations. We have 2D and 3D visualization. We have various base map styles, the ability to connect to remote servers using the Open Geospatial Consortium protocols like WMS, WCS, and the ability to display many geospatial file formats like KML, CSV, GeoJSON, and one that we use a lot. It's called CML, which is the Cesium language. That is a JSON schema, something like GeoJSON, but allow us to describe time dynamic geometries, a feature that we use a lot to animate some of our data visualizations, like glider trajectories, space-time, SAR regions and coverage. So we are seeing actually a demo of that in this image, in which we have stacked the coastal currents from high-frequency radars and the trajectory of a glider mission. And as we're seeing an animation, and the dot is moving, representing where the glider was in time. Some additional features some interesting features that this interactive map has is that we can show like a space and time dependent regions of where we have the data. So I'm showing that in this first image. And this example, I'm showing the regions where we have synthetic aperture radar images for that time. We have a slider control to modify the time-dependent data sets. We have a panel to modify the appearance of the map image, like the color scale, the style, etc. We can show custom plots made by our custom web service that I talked before, that connects the gap between what the AirDAP outputs, what the AirDAP server outputs, and what the interactive map can input. So for that, we are showing an example of that, where we have a current rows of showing current roses, and we can also show dynamic transect plots and explore time series in a single panel with multiple y-axis as needed for different variables. In this slide, I'm showing you more demos on how we present the data products. And this first image, I'm showing you the example of real-time and historical data from voice. We show them as dot on the map, and they have feature information of their measured variables, and we can explore that series by clicking them. And on the other side, I have an example of how how we show the glider trajectories and past missions and the animations of their trajectory, also as dots that have feature information within. We can also request them and create dynamic sawtooth glider plots for specific periods. Yeah, of course, we have the 2D and 3D maps using the CES. For 2D, we use leaflet. For 3D, cesium framework. And we can create the compositions of stacking data. For example, we have sea surface, height layer, glider mission, and trajectory, and the high frequency coastal currents. And this composition can be shared to college by creating this dynamic link. And this can be shared, and then another college can open that link and see the exact same creation that another user made. We have the ability in this inferior right corner, I'm displaying we have the ability to show third-party data sets through the standard protocols. So in that inferior right corner, I'm displaying the ocean currents from the SIGOM high-frequency radars, but also in the northern part of the Gulf, I'm showing the data from high-frequency radar network that is maintained by GCOOS, and the same map, the same time and point, and this can be done by the user by himself. For our near future, we're developing, we will be deploying and developing custom dashboards for a closer look on real-time data and generating visualizations. More custom-made dashboards to see more in depth specific products. And we're also generating visualizations within the interactive map to show the results of oil spill simulations that the SIGOM modulation group is producing right now operationally. I also want to highlight that we publish and maintain 2 open source Python library projects to improve the usability of our servers. And somehow we are contributing back to, we want to contribute back to the open source community, and has we been using a lot this type of software. And I guess we have gained a lot of experience on using these technologies, formats, the standards, and we strive for continue providing these services for hosting, distributing, and building specialized visualizations for the observational products and ocean models. We want to continue building and be ready when the time comes to collaborate with other observational laboratories within Mexico and the world. We want to have everything set to be compatible and interoperable with big groups within the integrated ocean observational system like GCOOS. And I guess we are setting the building blocks to be ready to do that. And so I want to thank you all for your time. I want to thank the GCOOS team for hosting us and giving us the time. And I'll leave here our contact information for collaboration or more in-depth details about what we are building in Smith. And thank you. I think that's all that I have for you guys for today. Thanks again.
Thank you, Favio. Excellent presentation as well. So we have some questions here, and before I get to the questions, I just briefly want to put in context how this project was obtained in terms of the funding. So this comes from the Ministry of Energy, Hydrocarbon Fund, and CONACYT, which is the Mexican equivalent of NSF. And the terms for developing the project were a little bit different. They were interested in us providing different products, particularly for making decisions in the cases of oil spills in Mexican waters, and the primary user was Pemex. There is no equivalent of NOAA in Mexico, so there's no centralized location or infrastructure for having these types of databases, so we had to develop a lot of them. There's a lot of interest in the consortium of maintaining different capabilities that we've developed, and we are working on that on different fronts. So I think that relates to some of the questions that you have. But right now, the project has an extension through, I think, the middle of next year for some of these measurements, including the gliders, the high frequency radars, some of the mooring systems and buoys, and then we will see what happens. That's kind of the broad picture. So having said that, Javier, you have a question from Stefan Howden, and he's asking whether GCOOS could display your surface current data on their data portal.
Hi. Yes, it should be. Actually, we used to have an MOU with GCOOS to work on that, but the MOU just ended up last year, I think. And yes, we just have to work a little bit on that, but is everything in place built for that? It should be straightforward to do that. And I think Fabio just showed the other way around, the Smith showing the GCOOS data. That's also another option.
Yes, thank you, Javier. And he has another question, and this is regarding your experience as to the amount of people that you have working with you. Have you found that 4 technicians is sufficient? Could you use more resources, or what are your main challenges to maintain the network that you are currently putting up and running, the whole network again?
Yes, I mean exactly the challenge of getting people. I mean, well-trained technicians and the funding, of course, because that's the real challenge. Right now, we have the technical part under control. We are autonomous in the sense that we build and fix and made everything we have to do with the technical part of the radars. We don't depend on, we don't rely on anyone, and that's a huge step, because back 10 or 15 years ago, we have issues on that, and we have to deal with the broken parts or components of the radar that we have to send to the factory, to the main factory to be rebuilt there, and that takes us a lot of time and resources in terms of exportations and importation and all the logistical part of that. Right now, we are not there anymore. Right now, we are autonomous. We can make everything here in Mexico in our labs, thank you to these open source radar systems. But the challenge now is to keep them running with the technicians and with the funding. So that's what I mean about the challenge of keeping the Mexican high frequency radar network.
Thank you. Fabio, there's a question for you from Nuno Simoes, whether you can provide some more information on the Australian data visualization platform. And there's another question regarding how you're sharing the seagull biodiversity data. That question, the second question, Nuno, I would ask you to ask me next week, because I'm in charge of that data. So all the geochemical and community biodiversity data is another data set, and I'm going to present that next week. So the question here is about the Australian data visualization platform.
Yes. Well, that's actually a framework, an open source framework that institution developed, and it's a open source framework in which we can build on top. We can they have built a lot of connectors to all these different data protocols on which they can get data, like of course WMS, WS, SOS, a lot of those protocols that are already there, and that framework is built like modular, on which we can add more connectors. But yeah, right out of the box, we can show GeoJSONs, we can show CSV files, and they're plotted like time series. We can show WMS layers, and that is an open source project that is continually developed, and it's called Terria.js, and yeah, we're using that to build our data visualizations, and we are been contributing back actually a little bit, but yeah, that's the information that I have from that project.
Thank you, Fabio. We have a question for Javier Brian Zelinki, who's from the IU's office in charge of surface currents program. He's a surface currents program manager. Who are your users, Javier, for the surface current data?
Sorry, I was mute. Hi, Brian. Well, our users in Mexico are mainly the Pemex, that is the Mexican Council of Oil, and the CENER, that is the Energy Council. And we have also users in the local governments, like for this, I don't know how you say that in English, Protección Civil. I don't know if you can help me with that, Sharon.
Protección Civil would be basically the agency in charge of safety.
Yes, something like that.
Mm-hmm.
But at the local level, in the cities, and I think the students also, of course, and the scientific community, everybody who is interested on the data is our main users.
Is Pemex using the data?
Yes, of course. We are redirecting the maps to Pemex. And I forget, of course, the Mexican Navy, the CEMAR. Also, we redirect the data to CEMAR. They have a similar system to SMIT. Favio may want to talk a little bit of that, because he's the one who is in charge of sending those WMS, I think, files to CEMAR, who also use the data through their purposes, to their common uses that have to be also with surveillance.
Thanks, Javier. So Stefan says that IU's is requiring 1 technician per 4 radars, and it seems like you have somewhere around 20, and in different parts of the country with 4 technicians and 1 PI. So I'm sure you're running around.
That's cool.
Yep.
That's one challenge.
Yep, I'm sure it is, because a lot of the places, I don't know how familiar you are with these regions where you have your radars for the public that's listening to this, but some of those locations are very remote.
Oh yes, very, very remote.
Mm-hmm.
But it's what we have here, and it's what we have to work with. So that's why my team is a total of I will say 3 real fully specialized technicians on high frequency radars, another 3 technicians that are for support and are learning right now. But with that, we have to deal with right now 17, 18 sites that are supposed to be working. Of course, it's a challenge. And of course, the ideal will be have 1 technician per site. But in Mexico, the reality is different. I don't think we will never have enough funding to have 1 technician per radar site.
Thank you. Brian is asking regarding, how you get permission from property owners. That is apparently a challenge for establishing and locating the radar network here in the U.S. I think your challenges are a little bit different regarding of where you put them and what happens. Can you share that experience, please?
Yes, that's a very good question, actually. Thanks for asking that, because that's a very important part that I didn't mention during my presentation. My strategy was to place radars in as much as possible educational institutions. So the 90 to 95% of my radars are installed inside schools, universities, institutions, also governmental institutions that have to be with the how do you say this? With the wildlife conservation, something like that. There is a few institutions, federal institutions that made that along the shore, and we also make contact with them, sign MOUs with them, and the rest, the other 5%, yes, is with just private owners that we go and talk with them and explain them the project, and they kindly allow us to put the radar there. I think I have 2 radars that are installed inside hotels. And we also share the data with these hotel owners, and they use the data to show to their guests, and sometimes they try to figure it out if the currents are high enough and kind of where they host on their hotels to avoid getting into the ocean. We have also, I think, 1 or 2 radars in the oyster plants that grow up oysters, and they also allow us to be there because they use the data to kind of figure it out when is a good time to pull water from the ocean into their pools and when it's not, because they can also use another sources of data to see if there is I don't know, a bloom of certain plants or a anomaly of the sea surface temperature or things like that, and they kind of decide when to pull water into their pools and things like that. So we kind of make everybody aware of the use of the data and the application of the data, and that's the way we have a lot of permits to install all this.
And I'm sure that helps with the safety of the equipment, right? Because otherwise you would have a lot of vandalism.
Oh yes, that's also another reason because we follow this strategy. Because if you just install the radars anywhere without making contact with the people, without making the people feel that the radar belongs to them and provide a service to them, then you are exposed to that, to vandalism, basically.
You have another question from Stefan regarding whether there's agencies in Mexico that are using the data for oil response and restoration and for search and rescue.
Yes, we are starting with all that, but yes, that's where we are heading up, especially with Pemex and with the Navy, Mexican Navy.
And I will add to that at the consortium levels, SIGOM is now a participant in the official plan for responses to oil spills. So this whole project was basically to provide different types of information, models, data sets, and inform decision making in the case of oil spills. So now we're in it. This is part of the extension of the project that we got through last year, is being fully integrated to be able to provide services in case of an oil spill.
Yes.
That's the last question I have here in the chat. Does anybody else have a question? I think people can open their microphone. I'm not really sure.
Sharon, this is Jen. To the attendees, if you do have a question and you want to raise your hand, I will unmute you. I don't think that there's a capability to unmute yourself.
I don't see any hands. Oh, there's maybe that was, Stefan, do you have another question or did you raise your hand earlier?
Hi, I just wanted to thank the speakers for a really interesting seminar. I really enjoyed it. It was
Wonderful. Thank you so much. And thank you all for being here and for participating. I know that obviously a lot of these data are not yet public. Some of them are, but not all of them. But there's a lot of interest to collaborate from SIGOM. So please contact us if you want to collaborate, establish connections. That's what we're trying to do. And we can facilitate this. Thank you. Jorge?
Sharon, well, thank you so much. I just wanna, well, by the way, I see that Brian Selenki has raised his hand. So maybe we should let him ask his question first.
Not a question, and I already took 2 of those, but I wanted to thank all the speakers today. I'm the lead for the United States HF radar network, and a lot of the lessons that you've learned here, I think will inform our program, and I look forward to opportunities to collaborate in the future. Thank you.
Thank you, Brian. Thank you for that. So if there's no more questions, I just wanted to again thank Javier and Fabio for the great presentations, for the amount of work that they've developed over the past 5 years or 6 years. It's really impressive, and this is really what we wanted to do with these webinars: give the opportunity for all of us in the northern part of the Gulf to become more aware of your great work. I also want to thank Sharon for her helping us with this program today, and just remind the audience that we will continue in a week from today on April 7th with webinar number 4 of the Renal Plan on environmental baseline and marine biochemistry. And Sharon will be a presenter of her work together with Dr. Juan Carlos Herguera from CISESE as well on those 2 aspects of the CIGOM project. And then the last webinar will happen on April 21st on renewable energies and technological developments, presented by the CENIE team. And we will have the opportunity to hear more about how they're using all these environmental new database and knowledge into renewable energies understanding and opportunities. So again, thank you so much. And just one last thing. These presentations and so will are the previous ones are now available, the recording in the GCOOS YouTube channel. So I'm not available to show that link with you today, but if you just Google for YouTube and GCOOS, you will be able to find all these presentations by, well, the previous ones are already there, and today's presentations will be available by today or Monday. Thank you so much.